Let's deal with the water cycle and the carbon cycle today. Before we look at these two important non-living cycles in an ecosystem, I just want to refresh your memory. We've already dealt with one cycle already, and that is the nutrient cycle. In an ecosystem, the sun provides energy to the earth, and producers convert that energy into food in the form of nutrients. And then those nutrients are passed on through food webs and food chains to consumers. And eventually, when everybody dies, we pass those nutrients on to decomposers who then pass them back to the producers by soil. This is a cycle. It's closed. It goes in a circle. There's give and take. Water works in a cycle, and we should respect water more because it moves around in an ecosystem. Let's look at the components to what we call the water cycle. One of the first components to the water cycle is how does water vapor get into the atmosphere? And that process is called two things: evaporation and transpiration. Transpiration is water evaporating from plants, and evaporation is water heating up in liquid form and going into the atmosphere. So both those two processes put water into the atmosphere. Next, let's look at condensation. Condensation is how all that water vapor forms clouds. So the water vapor forms clouds. The next process in the water cycle is precipitation, and so that's how it falls back down to earth, precipitation. Then the next process is called runoff. Runoff basically means that water then runs back down from higher elevations like the mountains to the oceans, and that's our process. So transpiration, evaporation into the air, condensation into clouds, precipitation back down to earth, and runoff back down to the oceans. So water moves around in a circle or a cycle in an ecosystem, which means we need to respect water. And if we don't respect it, then we can pollute an ecosystem and it could spread to other areas. One way we measure how pollution is going is through acids, bases, and pH. pH stands for the amount of hydrogen ion in a solution, and when something is neutral, that's healthy in an ecosystem. Neutral is pH 7, so the best type of water would be water pH 7. The more hydrogen ion, the more that number on the pH scale goes down to 4, 3, 2, and even 1, and it becomes increasingly acidic. The less hydrogen ion, the more it becomes what we call alkaline or basic, and it can be as much as 14 on the pH scale. So acidic substances are below 7 all the way to 0, and alkaline substances are above 7 all the way to 14 on the pH scale. We can use paper called pH paper to test to see whether water is neutral or basic or acidic. And one concern with pollution is acid rain. Acid rain formation is made by sulfur dioxides and nitrogen oxide emissions that come from factories and smokestacks on vehicles. Once these chemicals get into the air, they may wash back down to the ground in the form of acid rain, and that could cause the pH of soil as well as water systems to go below 4. And if it's below 4, it's not good at all. A healthy lake is about pH 6. Not much can live past pH 4. So acid rain and acid lakes are right around 4, but anything below 4, and fish, as it says here, fish will die. Here's what it used to be like in the United States when it came to precipitation. If you notice on the eastern part of the United States, there was some really bad acidic rain happening, almost so bad that it was hard for organisms to survive. The opposite of acid rain would be alkaline lakes. This is not a human-caused problem. We don't emit pollutants into the air to cause the rain to come down highly alkaline. However, some geology formations, rock, limestone rock, could be located next to a body of water, and that might cause the pH of the body of water to go highly alkaline, like 9 or 10, and it's hard for something to live in a highly alkaline lake as well. We test our pools, like this guy's testing his pool, because the pH of a pool is important to a healthy pool or hot tub. And what they're doing is they want to make sure that the water is around 7 for a pH, so that the stuff that you put in the pool to disinfect it, to kill any bacteria, only works at about pH 7. Most people use chlorine, and chlorine gets very ineffective above pH 7, or it also doesn't work if it's below pH 7. So we want to make sure that our hot tub or swimming pool is neutral so that our disinfectant works properly. So besides the carbon or water cycle, we also want to learn about another thing in the ecosystem, and that's carbon. Carbon cycles around like water. So let's look at different ways that carbon could get into the atmosphere. Humans breathe out carbon dioxide, and so do plants, and so that goes into the atmosphere through what we call respiration. Plants are so important to the carbon cycle because they bring carbon out of the atmosphere in the process of photosynthesis. Factories and automobile emissions put carbon into the atmosphere. Let's look at this clip on the carbon cycle so you can understand a little bit more about how carbon comes into and out of our atmosphere. It should be in balance, folks.
Dear Tim and Moby, what can you tell me about the carbon cycle? From Atoll. Well, carbon is the fourth most common element in the universe. It's the building block for all life on Earth. Every single cell and every living thing contains some carbon. Carbon is common in non-living matter too, in rocks and soil, dissolved in seawater, inside the Earth's mantle, and in the air as carbon dioxide. Earth's carbon is constantly flowing from one of these forms to another. That's the carbon cycle. It's like the water cycle, only a bit more complex. Animals add carbon dioxide to the atmosphere when they breathe, and plants soak up carbon dioxide during photosynthesis, storing the carbon in their cells. Plants, especially trees, are known as carbon sinks because they take more carbon out of the atmosphere than they add to it. The oceans are carbon sinks too. Thanks mostly to marine life, oceans soak up more carbon dioxide than they release. When plants and animals die, the carbon contained in their bodies enters the Earth's crust. Earth's crust keeps carbon locked up for millions of years, eventually returning some of it to the atmosphere through volcanic eruptions. Normally, the carbon cycle keeps a pretty steady level of carbon dioxide in the atmosphere. Lately, the cycle seems to have been thrown out of balance. More and more carbon dioxide is entering the atmosphere every year. It's probably because of human activities. We create tons of carbon dioxide by burning fossil fuels. And the clearing of rainforests in South America and Africa makes the problem worse in two ways. First, the burning trees add carbon dioxide to the atmosphere. And second, once the trees are gone, they're not soaking up any more carbon dioxide. Right, carbon dioxide is a major contributor to the greenhouse effect. That's the warming up that the Earth experiences because of certain gases in our atmosphere. Gases like carbon dioxide trap heat in the atmosphere and keep the Earth warm. Since the start of the Industrial Revolution about 200 years ago, the carbon in the Earth's atmosphere has increased by about 40%. Most scientists agree that this has warmed the Earth up and that the warming could have devastating effects on the environment. Planting forests and finding alternative energy sources will help restore the balance, but we've got a long way to go. should help too.
So let's finish this off by talking about the greenhouse effect. As he said before, there are many scientists that believe due to an imbalance in the carbon cycle, the Earth is warming up over time and its average temperature is getting hotter and hotter and hotter. And if this is the case, you could get catastrophic things occurring like the icebergs melting, which could cause sea levels or ocean levels to rise, etc. And so the greenhouse effect or global warming, they're synonymous, means that sun comes in as UV light and then it bounces and some of it leaves, but some of it bounces back as infrared radiation, which is a little weaker. Some of that leaves, but the thicker the cloud cover and the thicker our atmosphere, the more that will be trapped in. And if it traps too much in, the heat is reflected back into our planet, and that could warm up the Earth. We call this the greenhouse effect because this is like windows in a greenhouse. Our atmosphere traps in extra heat to keep it unnaturally hot. So hopefully this helps you understand the water cycle and the carbon cycle.